Hey, hello and welcome to today's GFG problem of the day. Hope you all are doing well. So let's see today's problem, flatten BST to sorted list. So we will be given a binary search tree. Okay. And what we want to do is we want to flatten this binary search tree into a sorted list. Okay. Into a sorted list. Now, if you see here, this is a sorted list. And the thing is what we want to do is we want to set all the left child of each element to null, and the right child should contain the element bigger than that. Okay. Okay. And we have to do this in O of one space. We don't have to take any extra space. Okay. Okay. So this is the condition. Okay. So let's quickly see an example, right? The same example we'll take. Now, what we can do in this example is, let's first see the naive approach, right? So what we're going to do, we will do in order traversal of the BST. Okay. And we will have an array. Okay. So we'll store the in order traversal of this BST in an array, right? So 2, 3, for example, 2, 3, 4. So you know the in order traversal of BST gives us the sorted elements, right? So right, 2, 3, 4, 6, 7, 8 we have. So we have this array, right? Now what we can do is for each element we'll take a node, right? We'll take a node, right? And then we will just put these elements into the linked list, right? And be with it. Okay. But this is a naive solution. So the problem says that we don't have to take any extra space. So we cannot use this solution, right? So now let's come to the solution with no extra space. Okay. So we are going to do in order traversal only. But what we will do is we will take one dummy variable first. Okay. Okay. So this is the O of one extra space. Okay. We are going to create one dummy variable, and we will set it with, for example, this is just a pseudo code, right? We'll set it with -1. Okay. We'll set it with -1. So we took one dummy variable, right? We set it with -1. And what we're going to do is we're going to set this dummy as previous. Okay. We'll have a previous pointer. Okay. Now for example, let's say that this is a root, right? Now we are going to do the in order traversal. We'll go to the left of 5, right? And then we'll go to the left of 3, right? We'll go to the left of 2. Now here it is null. So we'll return, right? We'll return here, right? Now, now we are done with the processing of the left child, right? Now, so what we are going to do now? So the current. So what we'll do, we'll set the previous of next, right? Previous of next to the current node, which is 2, right? To the current node. We are just modifying the pointers, okay? Which is 2, okay? Then what we'll do, we'll set the previous of null as previous of left as null, okay? As we'll be done processing with the left child, so we can set null. We'll see this in the, we'll see further, okay? So we have set this null, okay? And then what we're going to do, we'll mark the current as previous. Okay, we'll mark the current as previous, and then what we'll do, we will go back to 3. Okay, we'll go back to 3. Now 3 is left part or left subtree is processed, right? So what we'll do now, we will set the previous of next as 3, right? Previous of next as 3. And what we'll do, the second step, we'll set the left of previous as null. We can safely set as null because we are done processing this, right? 2. So we can safely, we're not going to come back. So we can safely mark this, the left child of the previous as null. Okay. Then what we'll do, the third step is to set the current node as previous, right? Then what we're going to do, we'll come to 4, right? The processing of right subtree, right? So what we're going to do here, yeah, we came to 4 here. We'll go to the left. We'll go to the left of 4. We'll return as it is null, right? So left subtree is processed. So now what we're going to do, we'll set the previous of next as 4. Previous of next as 4, and safely we can set the left child of 3 as null, right? Because we are done processing the left child, right? We are done processing. So in this way, and the third step is to set the current as previous, right? Okay, now we'll go back to 3. The left and right are processed, so we'll go back to 5. Now the left subtree of 5 is processed, right? So now in the in order, right? So what we're going to do now, we'll set previous of next as the current node. So current node is 5, right? Current node is 5. So we have set this, and we can safely mark the left child of 4 as null, right? Null. And then third step is to set the current as previous, right? In this way, we'll do the processing. We go to the right of 7, and then we go to the left of 6, left of 7. Then again, the left of 6 is null. We'll come back. And we'll set this, the previous dot next as, right? Previous dot next as 6, right? Previous dot next as 6, right? And we can safely point to the left child as null of previous, right? And we'll set previous as a current, right? We'll set the current as a previous, so 6, right? So then we are done processing. We'll go up to back to 7, and what we'll do, previous dot next 7, right? Previous dot next 7, here we'll mark null, and then we'll set current as previous. Okay, then we'll move to right, and again 8 will go to the left. We'll come back. After coming back, we'll set previous, right? The next 8, right? So this way, we'll set null. And then finally, what we're going to do, left of this as null, set as null, and right as also null. Okay. And finally, what we're going to do, so dummy is the head right now, right? Dummy is the head. So we'll simply return dummy.write. Dummy.write will give us the start, right? The start of the list. So this is the intuition. Let's quickly see the code. Okay, first we'll see the Java code as I've explained. So what we'll do, we'll take a dummy node. We'll also see the C++ code. Okay, we have marked dummy as previous, and then we are going to the helper. Okay, so what we're doing here, the base condition, definitely if the root is null, will return. Then we'll first process the left. We'll go to the left subtree, right? Once we hit the leaf, okay, once we hit the leaf, so what leaf, so what you're going to do, previous dot left will set as null, right? Previous dot right as a current, the second step, and we'll set the root as a previous, right? And we'll go to the right. So I've explained this, and finally, what we're going to do. So previous will be the last here, right? The last node. We'll set the left and right as null, and we'll return, right? Dummy dot right. Okay, so this is a Java code. C++ code is almost same. Okay, so here what we have, so we have so yeah, definitely we have created this dummy, that the dummy as previous. We are doing everything the same, right? And finally previous left and right null, and we are taking the right of dummy and deleting the dummy here. This is an extra step in C++, and we return the right. Okay, so let's submit the code. So yes, the solution is accepted. Please subscribe to my channel and like the video. Have a happy, healthy, and a great day. Thank you so much.